Let us look at proposition number 1 of book 13 of Euclid's Elements. The proposition says, if a straight line is cut in extreme and mean ratio, then the square on the greater segment added to half of the whole is 5 times the square on the half. So let's see what this means and how to prove it. Let the line AB be cut in extreme and mean ratio at C such that AC is greater than BC. Extend BA to D such that AD is equal to half of AB. So here AD is equal to half of AB. Describe the squares on AB and DC as AE and DF. So let's do that. So we have the square on DC and we have square on AB. Let's mark this point as E and let's mark this point as F. So DF is the square on DC, AE is the square on AB. Let's mark the other 2 points of these squares as L and K. Extend KA to intersect with the opposite side of the square DF and mark it as Q. Now draw the diagonal DF. Mark the intersection of DF and AQ as H. And now we draw a line through H parallel to DC. And let's mark it as P. Extend FC to KE and let's mark it as G. So now what the proposition is saying is that DF, the square on the greater segment plus the half the segment AB is equal to 5 times the square on the half. So let's see how we arrive at that. Now, rectangle AB by BC is equal to AC square. That is what cutting in extreme and mean ratio means. AB is to AC is equal to AC is to BC. Now, CE is equal to AB by BC. Why? Because CE is equal to BC by BE. But BE is equal to AB. So we can say CE is equal to AB by BC. So that is why CE is equal to rectangle AB by BC. Now FH is equal to AC square, which implies CE is equal to FH because AB by BC is AC square and AC square is equal to FH. Now BA is equal to 2 times AD because AD is half of AB. And BA is equal to KA. AD is equal to AH. So that means KA is equal to 2 times AH. KA is to AH as KC is to HC. How? Remember, parallelograms are proportional to their bases if they are of the same height. So here KC and CH are parallelograms and they are between same parallel lines. That means they are proportional to their bases. So that means KC is equal to 2 times HC because KA is 2 times AH. So KC will also be 2 times HC. Now LH and HC, they are equal. So which means we can write it as LH plus HC is equal to 2 times HC. So KC is equal to LH plus HC. How? Kc is 2 times Hc. LH plus Hc is equal to 2 times Hc. So that means Kc is equal to LH plus Hc. Now Kc plus Ce is the complete square. So Kc plus Ce is equal to what? Kc is LH plus Hc and Ce is equal to HF. So Kc plus Ce is equal to LH plus Hc plus HF, since HF is equal to C. So we have covered these three parallelogramic figures. So that means AE is equal to gnomon MNO. So let me bring in the gnomon. Kc plus Ce. Kc plus Ce is nothing but AE. LH plus Hc plus HF is equal to gnomon MNO. Now, since AB is equal to 2 times AD, which means AB square on AB is equal to 4 times the square on AD. Square on AD is nothing but DH. So we can say 4 times DH. Now, gnomon MNO is equal to 4 times DH, and the complete square DF is equal to DH plus the gnomon MNO. So we have DH plus 4 times DH, which gives us DF is 5 times DH, which is what we had to prove. So that is proposition number 1 of book 13 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.